Today we're going to be talking about insulin and glucagon for chapter 14. We are going to be focusing on the negative feedback loops and the effect it has on glucose in our bloodstream. So we're going to start with just thinking about our regular negative feedback loop. Today we learned about how our body wants to remain in homeostasis, and sometimes variables will knock us out of homeostasis. So normally we want to be here at the normal blood glucose levels, but we knock ourselves out of homeostasis when we eat a meal, for example. When we eat a meal, we take in a lot of nutrients. Those nutrients in the forms of macromolecules get broken down into single elements like carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. But all of those combine together to make a variety of different macromolecules, such as glucose. Now, when you eat a meal, this actually increases our blood glucose level, which is a good thing if we have the proper use of insulin. So when we increase the blood glucose, our pancreas is signaled, hey, we need to deal with this glucose that's in our bloodstream. So it activates the beta cells in the islets of Langerhans to release insulin. Insulin has 3 ways that it can remove glucose from our bloodstream. First, it can increase the permeability of the body cells to the glucose, which essentially just means it opens up the cells, the mitochondria take in the glucose, and we use it as energy. Or we can store it. There are 2 forms of storing it. We can store it as glycogen in the liver or muscles, or we can store it as fat. That is not far, it should say fat. I apologize. So insulin's job is to do these 3 things to reduce the glucose levels in our blood. If after doing those 3 things, we still have too much glucose in our blood, we create a negative feedback loop where it signals the beta cells again, and this process repeats. Eventually, by doing all 3 of these things, or 1 or 2, the negative feedback will eventually stop. Glucose levels will go back to normal, and we'll be back in homeostasis. Now, today we talked about diabetes. We talked about how a person with diabetes may be reliant upon insulin. Juvenile type 1 diabetes, the issue occurs at the beta cells where it doesn't release insulin, so insulin can't do any of those 3 things, which in turn means we have too much glucose in our blood. If you have diabetes type 2, then that just means that over time the beta cells have broken down, or you're not releasing enough insulin, so your body is constantly trying to release more insulin to make up for the lack of it until it burns those cells out, which we will talk about a bit more tomorrow. Now that our body's back in homeostasis, okay, there's just a couple of pictures here to show you kind of what is going on with the glucose in our bloodstreams when insulin is activated. So you can see the blood vessel takes glucose out of it and stores it in the cell. That's again, if insulin is present, it opens up channels and into the cell it goes. You can see the difference between the 2 types of blood vessels, a healthy one with normal blood glucose or a high blood glucose or hyperglycemia. Okay, it's not a healthy blood vessel, and in fact you can see the urine is what that's supposed to be, urea, around it as it is pulling all this stuff out and not allowing glucose to be absorbed. Now, back in homeostasis again, instead of insulin this time, we're going to talk about a hormone called glucagon. Glucagon means glucose be gone, essentially, is the best way to remember it. And what happens is when we are in homeostasis, sometimes when you're getting busy or don't have enough time in life to do something, sometimes you skip a meal, which again takes us out of homeostasis, which means our blood glucose levels actually decrease. When they decrease, the pancreas signals the alpha cells this time, not the beta cells, but the alpha cells in the islets of Langerhans to release glucagon. Again, glucagon kind of means glucose be gone. Why do we refer to it as that? Well, we want to remove glucose from our cells and add it back to our bloodstream. Without glucose in our blood, we can start feeling faint and dizzy and not feel very well. We need to keep that balance. So Glucagon releases glycogen from the liver or the muscles, and it goes and it breaks down into glucose, or we take our stored fat and break it down into glucose. Remember, glucose in our blood draws water into our blood vessels, which helps maintain a normal blood pressure. And so that's why you feel faint if you haven't eaten for a while, is your blood pressure starts to decrease. So glucagon's job is to take glucose out of our cells and put it back into our bloodstream. Again, if it happens and there's still not enough glucose in our system, then the negative feedback loop will occur. This occurs again until normal blood glucose levels are reached, and then we are back in homeostasis. So here's an example of what happens. Ignore epinephrine. We don't talk about that right now, but here is an example of glucagon signaling to the liver, hey, you need to take all these lovely different substrates and amino acids and stuff and reform glucose. So that's what it does, is it reforms glucose, releases it from the liver, and inputs it back into the blood vessel. So both of these negative feedback loops, if we think about them in terms of what we learned for diabetes today, we can see how insulin works. The glucagon doesn't have an effect. We're going to talk about what happens when you have low blood sugar tomorrow. It's called hypoglycemia. And we're going to discuss kind of some of the side effects of that.